Welcome to Back to Basics, presented by Dirts and Dims. I'm your host Tyre, and in this episode we'll be looking at four-wheel driving, so grab yourself a drink, sit down and enjoy the show. So some of you might ask, what is four-wheel driving? Well, I can tell you that the Oxford Dictionary says a four-wheel drive is a transmission system which provides power directly to all four wheels of a vehicle. A vehicle with four-wheel drive is typically designed for off-road driving. Having power to all four wheels of a vehicle allows better traction on uneven and difficult terrain. So now we know that the definition of four-wheeling is, let's look at the different components that makes up a four-wheel drive. So let's jump to Tyre and he can explain the different components. Thanks, Tyre. Now let's look at what makes up the mechanical components of a 4wding. So, like any other standard car on the road, a 4wding has a front and rear diffs as well as axles. What's different is what's known as a transfer case. Now, I can probably hear you saying, what the hell is a transfer case? Well, let me tell you. A transfer case's job is that it splits the engine torque from the gearbox from the engine, and rather than going to the one drive shaft which goes towards the rear of the vehicle, it then pushes it back to the front as well. So in turn, you now have four wheels turning at once rather than two, which allows for greater traction and less slipping out on the road, and also better stability when you're off-roading. In all four-wheel drives, the transfer case is either operated by either a toggle selector switch or a manual shifter, like in older vehicles. Now, back to you, Tyre. Thanks, Tyre, for that explanation on the transfer case. Now we're going to go to Tyre to explain the suspension components. Thanks, Tyre. Now let's go over the suspension components that make up a four-wheeler. So, we have two setups. We have live axles and independent front suspension, or IFS. Let's first talk about live axle setups. Live axle setups are most commonly found in Land Cruiser Utes, 79s and 75s, Nissan Patrols, GU and GQ, Suzuki Jimneys, Land Rovers and Jeeps. Now, a solid axle suspension, also known as live axle or a beam axle, houses the vehicle's diff in the actual axle itself, and they're connected to the wheels by rigid half shafts coming off the differentials. So, this means the entire axle works as one unit. So if a left wheel drops into a pothole or a hole, the right wheel in turn will move upwards to compensate. The benefit of a live axle setup is that you have greater wheel travel and more suspension articulation, also known as flex. The downside of a live axle setup is it just doesn't have the same comfortability as IFS. Now, let's have a chat about IFS. So IFS, also known as independent front suspension, as the name suggests, works independently of itself. So, if your left wheel drops, your right wheel will stay same on the road. Within IFS, there are two main common setups. There's a coil-over setup and a torsion bar setup. The coil-over works as a strut, or a gas shocker, and a spring coil. The spring coil is placed over the strut, and they work in unison to comfort the ride and take the load of the vehicle, and that's what's called a coil-over setup, where the torsion bar is a steel rigid rod that's connected to the chassis, and the other end will be attached to the control arm, either upper or lower, on the vehicle. So as the control arm moves in a fixed upwards or downwards manner on the frame, this creates a twisting motion on the actual torsion bar. This in turn supplies the torque needed to make the spring, which allows the comfortability of a IFS system with a torsion bar rather than a coilover. The downside of an IFS setup is that due to the short wheel travel and the actual travel of a control arm, either upper or lower, you have very limited flex and wheel travel compared to the live axle setup. But what you lose in articulation, you gain in actual on-road comfortability. Now you've had a look at both setups. Let's go back to you, Tyre. Thanks, Tyre. Now we've looked at the transfer case, suspension, let's now take a look at the centre diff lock and the front and rear diff locks. So, we'll go over to Tyre and he can explain it. Cheers, Tyre. So a centre diff lock works by locking the centre differential, which allows power to be divided equally between the front and rear axles, where, without one, all the power is gone into the axle with the least resistance. So, as the same way as a centre diff lock works, a front and rear locker works the same. The front and rear lockers are generally operated either an air operated locker or an electronic locker, also known as an e-locker. The downside of running an air locker is that you require an onboard compressor at all times to be able to power the locker. And the downside of an e-locker is they've been known to disengage if the vehicle rolls backwards with the locker engaged. So as the centre diff equalises power to the front and rear axles, the front and rear lockers equalises power to its respective axle. So if the rear locker is operated, it equalises power to both rear wheels, and the front with the same, and that allows to create more traction while you're out four-wheeling. You should also note that once the front locker is operated, that it stiffens both wheels, which means you'll lose a lot of your turning circle in your actual power steering. So you might have to turn it on and off if you've got to go around a tight hairpin bend. But the upside is you've got greater traction when travelling uphill. Thanks for listening. Back to you at the desk, Ty. Thanks, Ty, for that explanation on diff locks. So we've looked at the different mechanical components of four-wheel drive. So now, let's take a look at the theory behind four-wheel driving. So let's cross to Ty, and he's going to fill you in on things you need to consider when you're out in the tracks four-wheeling. Thanks, Ty. And now firstly, let's take a look at tyre pressures. Now, you're probably wondering, Ty, what the hell has air pressures got to do with four-wheel driving? Well, let me tell you. Dropping the air pressure in your tyres to suit different terrains will not only improve your vehicle's performance, but it also aids your tyre life and also stops damage to the tracks and the tyres of your vehicle. The way this works is by deflating the pressure in your tyres, you actually broaden the contact surfaces of the tyre to the road, which means you have more contact surface, which means you could actually grab more dirt or more rock to allow yourself to have that bit more traction. Now, you should always check your tyre manufacturer specifications on what pressures to run for mud, sand and hard pack surfaces. Now this can either be found on your dash or in the driver's door sill. So the next thing we need to look at when we're out wheeling on the tracks is gear selection. So first we're going to look at what drive selection we need. So there's three settings: two-wheel drive, four high or four low. Now two-wheel drive should just be used on the blacktop. You only need two wheels driving, so blacktop it is. Four high we can use on surfaces that we might need a bit more traction than the blacktop. So you might look at hard packed sand, loose gravel, hard packed tracks and dirt roads. And then we've got four low. Now four low should be used if we need that little bit extra slower pace, but that torque in there to be able to get ourselves up that sort of terrain. The terrain we'd use for low is deep sand, mud, snow, rock crawling, that sort of stuff. Now, we should also use it in declines and steep inclines, where we just know we need that little bit extra grip while we're going up or down. So, now we've decided what drive we're going to be in, let's have a look at what actual gear we can use. So, typically if we were going down a steep incline, we'd look at going four low and first gear. We don't want the vehicle running away downhill on us because that's going to end in disaster. But if we're going uphill, we might need that little bit more power just to power up that hill. So we're going to go second gear. But if you get to the bottom of the hill and it looks a bit dicey, you still might put it in first gear. Now, if we going up to the mud section and the hill's looking pretty muddy, we might go for a third gear or a fourth gear, because you can use that momentum to actually push you through some of that muddy and boggy section. So, we've spoken about tyres and we've spoken about gear selection. Now let's have a look at line selection. Now, line selection is deciding what path of travel you'll be taking, either up or down a hill or through the mud hole. So, there's a few factors we need to consider when we're choosing our line, like diff clearances, vehicle clearances, wheel ruts and cross slope. So, we're standing at the bottom of the hill and we're looking at going up this hill. Now, we can see that there's pretty big tyre ruts that are chewed into this track already. Now, if there's no cross slope on the track, we can straddle the ruts. And by straddling I mean, we can sit on top of the ruts and have those tyre ruts right underneath the vehicle. If there's a large amount of sloping on that track and the diff clearances can allow it, without having to winch too much, you can travel in these ruts to make it a little bit safer. If we're going downhill, we want to pretty much get into those ruts straight away. As we slide down that hill, if it's quite wet and slippery, those ruts are really going to lock us in, and we're not going to go sliding off down the side of the hill. The dangers of straddling these ruts if we're going uphill is sometimes your tyres might slip in and you can become what's called crossed up on the track, and the vehicle will start to turn on the track. This is quite dangerous because that's where it leads to rollovers. And the same thing can happen travelling downhill. So take it slow, make sure you're being safe. Now, choosing your line through a mud hole or a bog hole, you generally want to get a stick or a shovel if you have one on board, and you want to have a poke around in that hole and try and find where the shallowest part is, so you know that's going to be a safe path of travel. Last thing you want to do is get in there, have your diffs hang up on something underneath there, and you're stuck submerging your vehicle like a submarine. I've been there and it's horrible. So, now we're going to pass it back to Ty. Thanks, Ty. That was great. So now we should have a good basic understanding of what makes a four-wheel drive and how to four-wheel drive. So the next thing you need to do is hit the subscribe button, like the video, and comment what you'd like to see in the upcoming Back to Basics episodes. Also, follow my social media to stay up to date with upcoming news and upcoming episodes. And we will see you out in the tracks. This is Ty, signing off for today. And remember, if you got four wheels up in the sky, you've got a big problem.